Welcome back. In this video, we're covering a review of alkane nomenclature. Just so you guys know, oftentimes your OChem textbooks will have the IUPAC names in the appendix in the back of the book. Before going into naming alkanes, you should be aware of the 10 common alkane names. If you don't know them right now, you need to get on that. Naming will be so much easier and it will be impossible if you don't understand the prefixes for each. The 10 common names are listed here. Methane, or the methyl group, will have 1 carbon, ethane 2, propane 3, butane 4, pentane 5, hexane 6, heptane 7, octane 8, nonane 9, and decane 10. It's just as simple as that. They're not super difficult to memorize. They're pretty common names you see often, but you need to memorize those now. Some common branch points that you will need to know also are isopropyl, isobutyl, sec-butyl, and tert-butyl. There is no way getting around them. You have to know these ones. These are the 4 most common names you will see. Drawing them is relatively simple. It's just more of a memorization thing than anything. So an isopropyl is going to look something like this with an R group attached. Isobutyl is pretty much the same thing, just with 4 carbons. Again, with just any R group attached. A sec-butyl is also very similar, with an R group attached. And a tert-butyl is pretty easy because it literally just looks like a T with an R group attached. So you have to know these. There are a few others that they say are the common ones that are not nearly as common as these 4. These are the 4 that you really will need to know. Now to begin, there are 5 rules that you always need to follow when naming. The first rule is always find the longest chain first. It's the first thing you should ever do. The second is that the branches should be at the lowest possible carbon. The third being add prefixes if there are multiple of the same branch. Fourth, place branches in alphabetical order. And then the fifth and final is maximize your branches. And this might sound confusing, but we'll get to it. We'll start with one example. When you see something like this, like I said, you would find the longest chain first, and in this case, there's 7. So you'd go 1, 2, 3, 4, 5, 6, 7. And I mean, you could go this way as well, but either way, 7 is going to be your longest chain. So you know immediately it's a heptane. Now the branches should be labeled on the lowest number carbon, meaning we have methyl groups coming off of 2, 5, and 6. But if we flip the numbers, the methyl groups will then be on the 2, 3, and 6, which are lower numbers overall. So then we're going to want to start here and say 1, 2, 3, 4, 5, 6, and 7. Next, we would add our prefixes, which would be tri, since there are 3 methyls. Since there's 1, 2, and 3 methyl groups coming off, it would be a trimethyl. We won't have to worry about alphabetical order just yet, since this is a relatively simple problem, but like I said, on carbons 2, 3, and 6 are where the 3 methyls are coming off of, or the trimethyl. So you'd want to write it as 2, 3, 6, trimethyl heptane. And this would be the correct answer. Simple as that. Let's do another example with a little bit more complicated of a compound. Again, first find your longest chain, and in this case it will be another heptane. Go 1, 2, 3, 4, 5, 6, and 7. Make sure the branches are the lowest number of carbons, and as we have it in here, the lowest one is on the 2. If we went this way, the lowest one would be on the 3. So we're going to keep it the way we have it as far as numbering. The next thing you're going to want to do is find your prefixes. Since we have 2 methyls and an isopropyl, remember you need to know those names, it would be a 2,5-dimethyl and a 4-isopropyl, because you have a methyl group coming off of the 2 and the 5, and then your isopropyl is coming off of the 4. So lastly, you want to put them in alphabetical order. Now something to note is that prefixes other than iso and cyclo do not count when talking about alphabetical order, so you would actually use those prefixes rather than ignore them. So since we have an isopropyl, the iso is going to count, so we use the iso first. So as we know, it is a heptane since there's 7, but we would write it out as 4-isopropyl 2,5-dimethyl heptane. And this would be your answer. Let's try one more with a little bit more complex branching specifically. Again, find your longest chain, and in this case it's 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And since this one is symmetrical, we don't really have to worry about the directionality of the numbering. Next, we need our prefixes. On the 5th carbon, we have a propyl group with an ethane coming off. So what we would do is we would write in parentheses when we have a group inside of a group. So what we would get in parentheses would be 1-ethyl propyl on the 5th carbon, just like that. Also on the 5th carbon, we have 2 chlorines attached to a methyl group. So again, we would use the parentheses to denote dichloromethyl on the 5th carbon as well. So make sure it's in alphabetical order, and your answer should come out to 5-dichloromethyl 5,1-ethyl propyl. And again, since there's 9 carbons as the longest chain, it's a nonane. That right there would be your answer. I want to go over one last example before we end this video, and I want to do an example where you kind of have to work backwards and draw a compound based on the given name, rather than seeing the compound and write the name out. For this example, we're going to use 5,3,3-trichloropropyl 4,6-difluorononane. This may sound a little confusing, but we're just going to follow the rules just like we normally would when naming a compound. So we're going to start with drawing out the longest chain, and as we see, it's a nonane, so you can draw out your longest chain as 3, 4, 5, 6, 7, 8, 9. And then we want to start in the front, just as for our sake, so for our sanity, so it's just easier on us. So we can start as this being the 1 and this being the 9. It indicates that there is a propyl group with 3 chlorines coming off of it, and it's all attached to the same spot. So we go to the 5th carbon, right here, and we want to attach our propyl group, and then add our 3 chlorines coming off. So then you have your propyl as 1, 2, 3 carbons. So that's done. That's all there is to that one. And then the last one's a little easier because it tells us specifically that on carbons 4 and 6 there is 2 fluorines. So on carbons 4 and 6 you have a fluorine. that's exactly how you do it. You work just the same direction, only you're drawing it out from what you've read. Hope that you found this video helpful. Remember, you can get an A in OChem, and we're here to help as much as we can. Thank you so much for watching, and we'll see you next time.